Writing functions, vocabulary. Let's review some vocabulary regarding writing functions. The code I've highlighted here is a function definition. It defines a new function. You have to define the function before you can use the function. The keyword def means I'm defining a function, followed by the name of the function, followed by a parenthesized list of variable names, which are the so-called parameters of the function, followed by a colon, and then you indent, see here we're indenting the body of the function. Then below we have down here a call to the function. So once we've defined the function, we can use it, we can call it here. When you call a function, you have to provide the values that the function will use. In particular, these are called arguments, and the first argument, 1, will be assigned to the first parameter, y. So y will equal 1, and then z will equal 2, and then this code, the body, will be executed with y equal 1 and z equal 2. And then the function will hit a return statement. That's the statement here. Returns whatever value it hits, that's the result of the function, and it takes the place of the function call. The first time we call, the result will be 8, so in fact, the f of 1, 2 is replaced with 8, and we'll print 8. So we can call a second time. You can have as many function calls as you want, but you only have the one function definition. Now, in the literature, you might see these called formal parameters and these called actual parameters. We do not use that vocabulary. We just call these parameters, and these are arguments. When the function returns a value, say 8, that would be the return value. The return type would just be the type of that value, so it would be an int. So it's expected that this function returns an int. Curiously, it might return values that are not ints, because if I provide values, say, that are floats, say 3.2, the result would also be a float from this function. So functions can have different return types, and in fact, they can have any return type: int, float, boolean, string, any legal Python type. Looking at a couple other terms, we have statement and expression. A statement is basically it's a Python command. So this statement, and often, by the way, it's one line of code. So this statement is called an assignment statement. A variable name equals a value means to assign this value into this variable. So assign 5 into the variable x. This, of course, is a function definition statement. Statements can contain statements, as we see here. This is a return statement. Now this is a statement that will print a value. It's also a function call. So a function call by itself is a kind of statement. An expression is different from a statement. It's a part of a statement. An expression is a Python bit of code that evaluates to a value. An expression basically is anything you can put on the right-hand side of an assignment. If you can say x equals something, that something is an expression. So 5 is an expression, x plus y plus z is an expression, result is an expression, 1, 2, 3, and 4 are all expressions. F of 1, 2 is also an expression. And curiously enough, print, because it's a function call, so this whole thing is both a statement and an expression. Finally, there's local and global variables. So y and z are defined inside the function definition. When you place variables inside a function definition, they're known as local variables. They're local to the function. You can have variables besides y and z. I'll actually run this for a moment to show you. Inside here, I can declare a new variable, say like w equals 42. And because it's defined inside this function, w is also a local variable. So w, y, and z are all local variables. By contrast, x is defined outside of any function definition. When you do that, you get what's called a global variable. Global variable. X is global. Global variables are visible everywhere. So for example, here we are actually using that global variable. Global variables have some complicated rules about them, and we're not going to cover them because you shouldn't use them. Global variables are dangerous. When multiple functions use the same global variables, they step all over each other, and it leads to complicated errors, especially when different people write the functions And so they don't even know about the other's function's existence and that they're stepping on each other's globals. So we don't want you to write globals, and in fact, if you do use globals, you will lose points. However, people in the wild do use globals, and you have to know what they are and how they work. In any case, here you go. X is global, and Y and Z are local.